Hello everyone, let's start with today's topic called as Dijkstra algorithm. It is pronounced as Dijkstra because Dijkstra is a Dutch word found by a Dutch computer scientist Edgar Dijkstra in the year 1956. This algorithm is also called as shortest path first algorithm or single source shortest path algorithm. This is again a part of greedy algorithm I'm explaining. So let's start with the algorithm. We are going to take this graph as an illustration. So this graph is going to consist of five vertices A, B, C, D and E, and Dijkstra algorithm is going to work on both weighted directed graph and weighted undirected graph. That means it can be working on a weighted graph. Either it can be directed or undirected. So let's start with the algorithm. As told, this algorithm is going to work on single source shortest path. So let's begin with one vertex. It has to begin with one vertex. So any vertex we can take. So let me take the vertex A as the starting vertex. So I'm beginning with the starting vertex A. From this A, the idea is I have to reach all the vertices with the shortest distance. That means from A, can I reach B, can I reach C, can I reach D, and can I reach E is the question. And if I can reach, then what is the shortest distance I'm going to reach is the solution from Dijkstra's algorithm. So we'll start with the representation. First we are going to start with the vertex A. So let's begin with vertex A. A is a vertex which is a starting vertex, so I'm going to represent this with dash and dash where so in accordance with this, so according to the representation, this dash represents the edge from where it has come, and this dash represent the weight from where it has traveled. As this is a starting vertex, as I have taken vertex A as a starting vertex, A is having dash and dash. For easier representation, I have blurred the graph, keeping only the edges, weight of the edges and the vertices as activated edges, activated graph. After making the selection with respect to the starting vertex, we have to make sure that we are identifying the remaining vertices. So we have to identify the remaining vertices. What are the remaining vertices after identifying the starting vertex A? Vertex B, vertex C, vertex D and vertex E. So I'll represent this as vertex B first. So vertex B, what is the vertex B? Can I visit vertex B from A? If yes, directly. What is A? Is B adjacent to A? Yes, it is adjacent to A. So I can represent this as A comma 3 because A is visited, B is found, and B is found with the weight 3. Okay. So next one, can I visit vertex C directly or adjacent to A? No, this is not adjacent to A. So I am going to represent this as dash and infinity. This is represented as dash and infinity. So next one is vertex D. Can I visit vertex D from A? Yes, I can visit. So I have to represent from where it has to be. It can be visited. It can be visited from vertex A, and its weight is 7. Okay. So can I visit vertex E directly from A? No, I cannot. So vertex A is represented as dash comma infinity. Okay. So this is, so first step is completed, where I have identified all the vertices, remaining vertices, and as well as the starting vertex. So after identifying the vertices, I have to select one among them as the selected vertex. So amongst these, which are the vertices having the minimum weighted edge is this one. So this is the minimum weighted edge. So according to this, I am going to select vertex B as the chosen vertex. So with respect to this, I am going to select vertex B. Its weight it can be visited from vertex A, and its weight is 3. So this is the chosen vertex. So after identifying this, I am going to plot the graph. So when I am going to identify the chosen vertex, I am going to plot this with respect to the vertex chosen. So this is, I have chosen vertex B, so it is coming from vertex A, so it is coming from vertex A, so I am going to plot this edge A to B. So I have identified starting vertex as vertex A, and from A I can visit B because this is the shortest edge, so this has been chosen. So according to this, I have plotted this edge A to B, and I have chosen here A to B, and from A I can visit B, and its weight is 3. So now B can be visited with the weight 3. So this representation says us from where it has chosen from. For example, B is chosen and it has come from A. So A is here and its lowest cost is 3. So next visited vertices, next remaining vertices are C and D and E. So these are the 3 vertices which are to be yet visited. So I can visit vertex C. So I can visit vertex C from A. Can I visit vertex C from A? No, directly no. So I cannot visit vertex C from A, but I have one vertex which is intermediate to C. So can I visit vertex C from B? Yes, I have a direct path here. I have a direct path. So can I visit vertex C from B? Yes, I can visit vertex C from B. So what is this representation? So I can visit vertex C from B, and its cost is 4. But this is a single source shortest path algorithm here, where A is the source, B is not a source, but A is a source. From A I am going to visit C through B, so the weight is through B. So what is the cost to reach B? It is through A, so the cost is 3. So totally I am going to get this as C of B comma 7 is the weight to reach the destination C. So the route may go something like this. From here the route may go from A via B to C. So this is the visited route. I can go from A to B, B to C. So what is the total weight? Weight is 3 plus 4 is equals to 7. So this is identified as 7. So this is important in a Dijkstra algorithm. Here the total cost from the source has to be identified to reach the destination C. So next destination is what? I have to reach the destination D. So to reach D, can I reach D directly from A? Yes, I have a route. So I'll represent this as I can reach D from A and its cost is 7. Okay, but I also have vertex B to reach D. So I can reach from D also. So for example, let's see, can I reach from A directly? Yes, I have the route here, A to D. Okay, so I'll change the color. I'll choose blue color to represent. So I can reach D from A and its cost is 7. Okay, so this is 7. So next, but I also have an route from B. I also have a route from B. I can reach vertex D from B also, and its cost is 2. But B is not a source, A is a source. So from A to B to D I can reach. So what is the cost to reach this? It is 3 plus 2 is equals to 5. So amongst 7 and 5, which one is the cheapest cost? So I have D, and I can reach from B, and its weight is 2. B to D is 2 plus the source is 3. So totally it becomes 5. So amongst this, D of B comma 5, which one will be feasible for us? So I can choose this vertex. Okay, so I'll be ignoring this vertex. I'll be ignoring this vertex B vertex a comma 7 is ignored, and vertex d comma 5 is selected vertex. So I am going to select this. Next, can I visit vertex E directly from A? No. Can I visit vertex E from B? Is again no. So it is dash and infinity. So this is dash and infinity again. Okay. So amongst these, which one is having the lowest cost? Amongst these, which one is having the lowest cost? So I have C of B comma 7, I have D of B comma 5, I have E of dash and infinity. So amongst these, I have the lowest cost which can be visited is D of B comma 5. So next vertex, selected vertex would be D of B comma 5. So I am going to choose this vertex D of B comma 5 as the selected vertex. So once I make the selection, I have to plot the graph. So when I am plotting the graph, I have to make sure that I am choosing which graph I have chosen now, which edge I have chosen. I have chosen the edge D to B. So I have to plot this edge. So I am going to plot this edge. So I have plotted B to D edge which is selected. So from here, this 3 vertex or selected vertex, I am going to get the visited vertex and their weight. So for example, A is there, so this is the starting vertex, dash and dash simplifies that, and B of A comma 3 makes us understand that B can be visited from vertex A and its cost is 3. Then D of B comma 5 makes us symbolize that D can be visited from vertex B and its cost is 5. That means D can be visited from vertex B and its cost is 5. How it is 5? It is from the source we have to take. So A to B, B to D is 5. 3 plus 2 is 5. So this is what we are getting from this graph. So after selecting the items from the edges, we have to now go on selecting the remaining vertices. What are the remaining vertices? We have remaining vertex C and vertex E. So vertex C and vertex E are the remaining vertices. So to visit vertex C, can I go from A? No, because this is not adjacent, but I can go from B to C. So what is the weight to visit C from B? I can visit C from B and its weight is 4, plus the cost of B is 3. This is the cost of B. So here I can get the cost of B. So cost of B is 3. Okay. So this can be written as C of B comma 7. Okay. So next, this is not the only edge I can go, but I can also go from here. For example, I will show it with respect to the plot. So I can go from B to C. I can go from B to C. This is 1. This can be traveled from A to B, B to C. It can be going from like this. So the cost of this is 3 plus 4. So 4 plus 3 is the total cost I am getting. But I also have an edge from D to C. So I also have an edge from D to C. It can be going from D. So from D to C I also have an edge. But this edge is coming from A to B, B to D, D to C. So this is coming here. The weight of this is 3 plus 2 plus 5. This becomes 10. So I can write it something like this. I can write it C of D comma 5 is the C to D edge, plus 5 is the edge to reach D. So this is edge D. So this is 5. Done. So amongst these two, I have this as total 10 weight and I have this as 7. So amongst these two, I am going to choose C of B comma 7 as the selected edge among these two vertices, these two edges. Now next is I have vertex E. Vertex E can be chosen with respect to vertex B and vertex D, but vertex E also. So A to E I don't have any edge directly, B to E I don't have any edge directly, so I am forced to choose the vertex E only, vertex E, which can be chosen from vertex D, and its cost is 4, plus the cost to reach D is 5. So this is equals to E of D comma 9. E of D comma 9. So amongst 9 and 7 I can choose the vertex which is shorter. So 7 is the vertex which is smaller than 9, so I can choose this vertex as C of B comma 7 as the selected vertex. So once I choose a vertex from where this C has been selected, it has been selected from vertex B. So I have to plot a graph, plot a line from B to C. So I have drawn a line from B to C and its cost is 4. So the total cost to reach C is from B. So B, so I have 4 as the weight and 3 as the intermediate weight. So total weight to reach C is A to B is 3, B to C is 4. So 3 plus 4 is the total weight I got to reach 7. So finally we are left with only one vertex which has to be reached, and that is vertex E. So vertex E can be reached. Vertex E, can I reach vertex E from A? No, because this is having an intermediate node. Can I reach vertex B directly? No, again B is impossible. So yes, I can reach an vertex E from C. So I can reach vertex E from C and its weight is 6, plus the intermediate weight to reach C is what? 7. So I have to represent the 7, because I can reach C from 3 plus 4, 7. 7 plus 6 is the total cost. So this can be written as E of C comma 13. So is the total weight. So can I reach vertex E from vertex D? Yes, I can reach directly. So it can be represented something like this: D comma vertex D to E is vertex weight 4, plus the weight of D is what? It is 5. Weight of D is 5. So weight of D is 3 plus 2 is 5. So this is going to yield us E of D comma 9. So I have two answers for the same vertex. So I have C comma 13, which is greater than D comma 9. So I am going to make a choice of E of D comma 9. So now finally we can choose an vertex E with the D as an intermediate node and 9 as a cost to reach this. So what is the vertex left now? I don't have any vertex, so I have to plot a line from D to E. After drawing a line, I am going to get this line from D to E. So this is the line drawn. So after drawing the line, I am going to get this graph. So did I finish with all the vertices? Yes, I have finished with all the vertices. From A I started. A is an first node. From A I went on reaching B, so I got vertex B. Okay, after getting vertex B, from A I went to B and I reached vertex B. From B I went on reaching D. Okay, from A I reached B, from B I reached D, then from B again I reached C, then from D I reached E. So this is the route which I am traveling. From A, can I reach B? Yes, and its cost is 3. Okay, from A can I reach C? Yes, its cost is 3 plus 4, 7. Okay, the route goes something like this. From A can I reach D? Yes, I can reach. So its root is something like this. It is 3 plus 2 5. From A, can I reach E? Yes, I can reach. Its root is something like this: A to B, B to D, D to E. So this is the root. So this is how we are going to devise the minimum cost. Finally, I got this graph after placing the vertex D to E. Now from this graph we can see that A can be reachable from B. Yes, A can be reachable from B, and then this can be represented something like this: can I reach A to B? Yes, and its cost is 3. Okay. Can I reach A from A to C? Yes, I can reach, and it can be reached from A to B. It can be reached from A to B, and it can be reached from B to C. So it is 3 plus 2 plus 4 is equals to 9. Sorry. It can be reached from A to B, B to C. Its cost is 3 plus 4 is equals to 7. Okay. Then can I reach A to D? Yes, I can reach. It can be reached from A to B, then from B to D. Okay. So its cost is 3 plus 2 is equals to 5. Can I reach A to E? A to E, yes, I can reach. So it can be reached something like this: A to B, A to B, then from B to D, then from D to E, D to E. So the cost is 3 plus 2 plus 4, 2 plus 4. So the total cost is 9. So these are the vertices I can reach from vertex A. So I can reach from vertex A to B, vertex A to C, vertex A to D, vertex A to E. So these are the routes which I am going to travel to reach each vertices. So this is a single source shortest path. That means from single source vertex A, single source or single vertex, can I reach all the vertices is the solution. So this is using Dijkstra algorithm. Okay, thank you.